In this video, we will discuss reading circle, bar, and line graphs. A graph shows information visually. They give us useful information at a glance if we interpret them properly. Three common graphs are the circle graph, or pie chart, the bar graph, and the line graph. To read a circle, bar, or line graph, first read the title of the graph to determine what information is shown. Then examine the parts to see how they relate to one another and to the whole. Then examine the labels for each part of the graph and any explanations given. Then use the given information to calculate additional amounts or percents. To read circle graphs, a circle graph or pie chart uses a circle to show how a whole quantity is divided into parts. There's an example on the next page. The complete circle represents the whole. The circle is divided into parts so that the sum of the parts is equal to the whole quantity. These parts can be expressed as fractions, decimals, or percents. Here is an example of a circle graph or pie chart, whichever you want to call it. Here we have the description. It's a distribution of wholesale price for a $425 color television. This key tells us which part is associated with which color. So this red wedge is tariffs or taxes. The orange wedge represents overhead. The green wedge is profit. The blue wedge is labor, and the purple wedge is materials. We'll use this pie chart for an example. Use the figure above to answer the questions. What percent of the wholesale cost is the labor? The wholesale cost is $425 and the labor cost is $130. 130 divided by 25 times 100% is 0.30588235529 times 100%, and that's about 30.6%. Remember that we'll always round our percentages off to the nearest tenth. What percent of the wholesale price is the cost of materials? Materials cost $125, so we repeat the process, just changing that 130 to 125. 125 divided by 425 times 100% is 0.294116776,471 times 100% is about 29.4%. Finally, what would the wholesale cost be if no tariff were paid on imported parts? So here we just take the price and subtract the tariff. The wholesale price is $425 and the tariffs are $40. So 425 minus 40 is $385. A bar graph uses two or more bars to compare amounts. The bar lengths represent the amounts being compared. Bars can be drawn horizontally or vertically. The axis that runs along the length of the bars is a scale of the amounts associated with the lengths of the bars. The other axis labels or gives a description of the bars. Here is an example of a bar chart or a bar graph. Each bar represents company oil production in a specific year. Along this side, we have the years. And here we have a scale of the number of barrels of oil in hundreds of millions. So we'll use this to answer some more questions. How many barrels of oil did the company produce in 2014? We look at the chart for 2014, this orange bar, and we slide down here and see that's just about 4 million barrels. And there's the answer down there. Next we ask, judging from the graph, should the amount of oil the company produced in 2019 be more or less than in 2017? Well, we can see from the chart that the amount is growing. Every year, they produce more oil than the last. So we should expect that in 2019, there should be more oil produced than in 2017. Finally, we're asked, how many more barrels of oil are indicated in 2018 than in 2014? Well, we can see that there are about 575 million barrels of oil produced. I think it was supposed to be, yeah, no, this is good. I just wrote numbers down wrong. Okay, so we can see that in 2018, about 575 million barrels of oil were produced, and we know that in 2014, there were about 400 million barrels produced. So we just subtract 575 million minus 400 million is 175 million barrels of oil produced. Finally, we'll talk about line graphs. A line graph uses one or more lines to show changes in data. The horizontal axis in a line graph usually represents periods of time or specific times. The vertical axis typically represents numeric amounts. Line graphs show trends in data and high and low values at a glance. So here we look at a graph that shows a patient's temperature at specific points, particularly from at intervals of 4 hours for 3 days, or 2.5 really, because they stopped at noon on the 3rd day. And we can see it starts up here and it's getting lower and sort of balancing out toward the end. We'll use this to answer some more questions. On what date and at what time did the patient's temperature first drop to within 0.2 degrees of normal? Well, normal is 98.6 degrees. So it's going to be closest to normal here, or within 0.2 degrees of normal here at 98.8 degrees, and that's at 4 a.m. on the 11th of April. 4:11 at 4 a.m. Next question asks, over what period of time did the patient's temperature remain within 0.2 degrees of normal? Well, it's within 0.2 degrees of normal here and all the way to the end, from 4:11 at 4 a.m. through 4:12 at 12 p.m. Finally, what was the highest temperature recorded for the patient? That's way back here at the beginning, 102.2 degrees.